Apollo 8 was the shining star that drew 1968 to a close. Christmas Eve and Apollo 8 gave the world its first full look at itself from over another horizon.
Oh my God, look at that picture over there. There's the Earth coming up. Wow, is that pretty?
A young engineer at the time, Bill Kilpatrick, remembers exactly where he was when Apollo 8 crew members read from the book of Genesis.
In the beginning.
He was in the HOSC on console. With Marshall's part of the mission successfully completed, and with his junior status on the team, he was alone there.
Well, at the time, I was excited, but you were caught up in the events. And even in a short period of time, you'd become integrated. Probably means more to me today, looking back. I just can't imagine a career that would allow me the opportunity to be a part of history and to be probably the only one in Huntsville that was hearing those words in real time.
Apollo 9 stayed in Earth orbit. Apollo 10 was a dress rehearsal. Again, the critical S-4B restart and burn. And Apollo 11 made the national goal a reality.
Dear men from the planet Earth, first set foot upon the moon, July 1969. It came in peace for all mankind.
The job of the HOSC did not end with the S-4B second burn. Once the Command Service Module and Lunar Module had separated from the S-4B stage, the HOSC team's job then became to ensure that the S-4B did not impact the Moon near the lunar landing target, nor return to a potential Earth impact. Working with the Marshall Flight Control Team in the Houston Mission Control, the HOSC was charged with ensuring the safe disposal of the S-4B instrument unit. Clark Owen was a young propulsion engineer in the HOSC.
Beginning with the first landing mission, we did a slingshot. We used lunar gravity to slingshot and cause the S-4B to go, in our instrument unit, to go out into deep space.
However, beginning with Apollo 11, each moon landing emplaced a seismometer on the lunar surface to measure seismic activity. These created a new need.
The scientist that was responsible for that study did not have a calibration. In other words, if he saw some kind of reading, he didn't know he could read the magnitude but didn't know the significance of it, more or less. It's my understanding. And he, through the agency, said, hey, can you impact the S-4B stage on the moon? You had a known mass and a reasonable knowledge of the velocity, so this would give him an adequate calibration. And he defined to us a target that was 250 kilometers by 250 kilometers that he wanted hit inside of. And we had a team at Marshall that was responsible for the primary calculations, and it was backed up in a more manual that had just come out, handheld calculators at that time. As I recall, out of the 4 or 5 that we did, even in a crude fashion that it was done, we hit within the 250 kilometer zone all but one of those times, and we weren't very far out then.
A key engineering asset of the Saturn program, the key engineering achievement of the program, was the Saturn V breadboard facility. For the Saturn vehicle, the Launch Control Center and the pad were several miles apart. And to control the vehicle and the sequencing, there were 2 RCA 110 computers, one underneath the launch pad and one in the Launch Control Center that had to talk to each other. And in those times, no one had made 2 computers talk to each other over that kind of a distance with the precision that was required for the sequencing of the Saturn V. So this was a technology advance. And the breadboard facility duplicated those 2 RCA 110 computers and all of the hardware of the electronic hardware of the vehicle. And they even went to the extent of running the same cables, the same length of cables, the same type of cables between the 2 RCA 110s and the breadboard facility. Cables went out the door, down the road, wandered around the Marshall campus, and then came back to the other RCA 110. And they even went to the extent of burying it in beach sand that was trucked up from Cape Canaveral to be sure they had the same electrical characteristics.
A technical problem arose during the countdown of Apollo 14. The engineers at the launch site and in the HOSC thought they knew the solution. Marshall engineers used the unique breadboard facility to verify the fix and successfully launch Apollo 14 within the narrow launch window.
We have liftoff of Apollo 14, 3 minutes past the hour.
Apollo 15 brought something to the lunar expeditions that truly did open up new horizons: wheels. The Lunar Roving Vehicle, or moon buggy, was an ingenious car that was built in Huntsville and in the very short time span of 18 months. Astronauts David Scott and Jim Irwin first put the fold-up car to work exploring Hadley Rill, but only after some steering problems were sorted out.
You know what I bet you did last night, Joe? You let some of those Marshall guys come up here and fix it, didn't you? It works, Dave? Yes, sir. It's working, my friend. Beautiful.
A Marshall team of engineers in the HOSC supported the rover on the lunar surface through each mission.
We would look at each time the rover went out, evaluate its performance, evaluate how much the batteries would recharge while the crew was back in the lunar module resting and regrouping for the next EVA.
The HOSC continued to support the lunar rover on Apollo missions 16 and 17. The final performance of a Saturn V and the last Apollo mission to the moon launched at night. Aboard were Gene Cernan, along with Ron Evans and Harrison Jack Schmidt. All looked well as the countdown progressed, but
we have a cutoff at T-minus 30 seconds. This cutoff was automatic, done by the sequencer.
Apollo 17's onboard computer erroneously believed an upper stage fuel tank was not pressurized. In reality, it was all set to go, but the computer didn't know that.
And I kept wanting to know, what's it looking like? What's going on? What are you thinking down there? Because I knew we had all the people from Huntsville working feverishly down there. They were not going to allow us not to go if it was possible to go. The other side of the coin is, I knew that that they were not going to allow us to go if they had any concerns. So I had ultimate confidence.
Now, in order to fix that, it's my understanding that the HOSC in Huntsville and the launch control team immediately began to work on a fix. I believe it was a hardwire fix, as a matter of fact, in the computer, and to test it out and make sure everything was fine. And 2 hours and 40 minutes later, we were on our way.
We have a liftoff, and it's lighting up the area. It's just like daylight here at Kennedy Space Center as the Saturn V is moving off the pad.
After Apollo came Skylab, the first U.S. manned space station. Skylab was launched on a modified Saturn V vehicle, where the upper stage, the S4B stage, was actually the Skylab itself.
Skylab has cleared the tower.
The Saturn V launch was to be followed by 3 Saturn 1B launches at intervals of 30 to 90 days, carrying 3 different crews up to live in the Skylab. The plan for the HOSC was to fully man during the launches and the deployment of the Skylab, but then a low level of activity, mostly on-call kind of support during the long-duration missions.
Well, Skylab was our first space station and was an outstanding opportunity to learn more about spaceflight and the things that can go wrong.
During the ascent, we had the meteoroid shield was torn off by aerodynamic forces. The meteoroid shield had our thermal protection paint on it, which was designed to keep a comfortable environment within the capabilities of our thermal control system inside, and also to protect the structure. Well, when the meteoroid shield came off, we lost that protection. Temperatures went off-scale high, and obviously we were in no condition to man the thing. So we had to get it under thermal control.